Okay, we are going to be doing horizontal stretches and compressions. Now, I have a graph up here which shows it shows a horizontal and stretch and compression of a quadratic graph. In the middle, right here, this graph, that is the graph of y equals x squared. So you have that graph of y equals x squared. To compress it, think of it like this. If you've ever watched a horror movie, somebody always ends up in a room where the walls come crashing in like this. So when the walls come crashing in, that's a compression. You're being compressed, and we're always thinking, get out, hope you get out in time. And then when the walls go this way, that's not a compression, that's a stretch. And on the x-axis, which is our horizontal axis, that is a compression. This is a stretch. So when we see the graph of x squared, which is right here, for it to be compressed, it's coming in this way. Now, it looks like a vertical stretch. It looks the same. They are a little different. A vertical stretch, you see this here, this equation here. The 2 is not inside parentheses. That's how you'll know the difference. So a vertical stretch will not be in the parentheses. It'll be outside. A vertical compression, however, will be inside the parentheses. And so you have that one there inside. A horizontal stretch, just like the walls coming out this way, a horizontal stretch takes that quadratic graph and goes out this way. So that's a horizontal stretch. And it will be inside parentheses. Now I'm going to go into more detail with that here on the next slide. This slide here shows, it's an exponential graph, but it shows a horizontal compression. Now, horizontal movement just blows our mind. The other day I did a video on horizontal left and right, how it shifts left and right. And we were fine with vertical. Vertical, a plus sign meant it went up, the graph went up. A minus sign meant that the graph went down. But with horizontal compressions, the opposite of what our mind thinks ought to happen happens. So when we have a plus sign with a horizontal shift, instead of it going to the right, which is what our mind wants it to do, it actually moves the graph left. And a minus sign will move the graph right, which is opposite of what our mind wants it to do. The same thing happens with a horizontal and a compression and stretch. So this here is just, you'll see it and it'll look like this, 2x. And with an exponential function, it will be with where the exponent is, or up in the air. Okay, that's horizontal movement. It is not a stretch. Our brain, because we've already, when we do vertical stretches, which we did yesterday, and a vertical stretch of 2 will look like this. It'll look like 2 times 2 to the x. The 2 will be out front. That's a vertical stretch. When it's inside the parentheses like this one is, that's not a vertical movement, that's horizontal. And it's not a stretch, it's a compression. And so when we write it though, we don't write it as a horizontal compression of 2, we write it as a horizontal compression of 1/2. We actually take that number, because 2 can be written as 2 over 1, and we flip it, we invert it. So it's a horizontal compression of 1/2, and I did another one here that had a different fraction. So you've got 2/3 x. So when you flip that one, it's a horizontal stretch of 3 over 2 because that number is less than 1. So greater than 1 is actually a compression now, and less than 1 is a stretch. So you see the graph over here, I've graphed it. You're going to be using Desmos. And so you'll put this into Desmos and it'll be easy enough to find the graph. But the original graph is here in black, and this one's been compressed by 2. That just means that I'm multiplying my y values by 2 with every x. But anyway, it ends up being up here this way. All right. Now, this one, again, this is not a compression, it's a stretch. It's a horizontal stretch of 2. I did not graph the parent graph here. I just did the graph of 2 to the 1/2 x. And remember, you're going to be using Desmos. You're going to put that into Desmos. There's a table function in Desmos. Hit the table function and use it to help you graph these graphs. All right. This is a horizontal compression of 1/3. I've gone away from the exponential function and now I'm doing quadratic. If you remember the quadratic function, the parent looks more, oops, got that in the wrong spot. The parent looks like this, and I won't get every point exactly right standing here doing it this way. But that's the parent, and then it is compressed. Remember, it's coming this way. It's like being in the walls. Although it looks like a stretch, it looks like a vertical stretch. They look the same. They are not the same. They won't have the same values. So it's important that you put this into Desmos and graph it. But it is compressing the graph from the sides this way. So that's a horizontal compression of 1/3. All right, this one, because it's 2/3, it's smaller than 1, is a horizontal stretch of 3/2. And the original parent graph did get stretched out this way. The parent graph is here. And it is stretching it out. That's the parent. Again, Desmos will help. All right, now I just put these up for my class today and I'll go over one of them. I just wanted you to see what you're doing. This is a quadratic. This over here is your vertical shift and it goes up because it's a plus sign. Inside the parentheses is horizontal. This goes to the right 1. Remember, horizontal does opposite of what our mind thinks it ought to. This is not a stretch because it's inside. It's a compression of 1/2, and that's a vertical stretch of 3. Remember, our vertical movement is out of the parentheses. Thank you.